Hey guys, welcome to the 2019 Level 2 Mechanics Physics paper walkthrough. So question 1, the hockey match. Nicole is playing for a school hockey team. During the game, she passes the ball to her teammate Josie, who is some distance away. To do this, she has to raise the ball high enough to give it flight and low enough to keep it safe. She hits the ball with a velocity of 22 meters per second at an angle of 30 degrees. Alright, question A. Show that the initial vertical velocity of the ball is 11 meters per second. So initial vertical velocity, that refers to the vertical component of the velocity. So as you can see here, we have a right angle triangle, so we can apply SOHCAHTOA. So this angle is 30 degrees, and we can say that this vertical here is the is the vertical velocity VV, and the horizontal velocity is the VH. So we have the hypotenuse is 22 meters per second, and we're trying to find the vertical velocity. So we can use the relationship of sine 30 is equal to the vertical velocity over the 22. And sine 30 equals to 0.5, so our vertical velocity is equal to 11 meters per second. And that should be just an achieved question for this one here. Describe and explain the motion of the ball. You should refer to any forces acting on it as it moves through the air. You may include the diagram to support your explanation. So this is a pretty common question. So the important terms you have to remember is horizontal component remains the same. And this is because there's no external forces. So there are no external forces or horizontal direction. And that's assuming that air resistance is negligible, of course. Assuming air resistance, negligible. Hence, you can just say, the horizontal velocity remains the same for the whole flight. So, hence, VH remains the same. Okay, talk about the vertical velocity will change. This vertical velocity will change, and this is because there's a vertical force is a vertical force of gravity that acts on the ball. Okay, so vertical velocity is important to note down that for the first half of the flight, that the force of gravity is acting in the opposite direction as the vertical velocity, because when the ball starts, it starts moving upwards because the vertical velocity is in the upwards direction. However, gravity acts downwards, which is in the opposite direction. So for the first half of this flight, they will cancel each other out, which means that gradually the vertical velocity is going to decrease due to this force of gravity. This is at the max height. We know that the vertical velocity reaches 0, which is basically the turning point of the motion, okay, and then the ball after that will begin to accelerate downwards. So basically for the second half of the flight, the ball will have a downwards acceleration because gravity is now acting in the same direction as the vertical velocity. So the ball is going to accelerate downwards, and it's going to follow that parabolic path there. So we can say, in terms of this question, we can say for the first half of the flight, for the first half of the flight, we can just say FG acts in the opposite direction of the vertical velocity. Hence, the vertical velocity reduces at max height. At max height, you can say VV equals to 0 meters per second. And then you can say for the second half of the flight, For the second half of the flight, the force of gravity acts in the same direction as the vertical velocity. Hence, the ball accelerates downwards. So that should be a typical answer for this question. And in terms of drawing the diagram, I'll do it at the very back. Drawing the diagram. Alright, so in terms of the diagram, you know that the ball is going to follow a projectile path. So it's something like, that's not very good. So yeah, that's good enough. Alright, so this ball, okay, is going to start out with a horizontal component, which is VH, let's say horizontal component. Actually, let's do this arrow, might be better. Alright, so it's going to start out with an initial horizontal component and an initial vertical component. However, we established that the horizontal component will remain the same throughout the whole flight. So basically the length of the arrow representing the horizontal component is going to be the same throughout the entire flight. Okay, so we're going to duplicate again. At the max height, it's still going to be the exact same as when it started the flight. Duplicate. So this, yeah, like I was saying, this this horizontal component will remain the same no matter what. However, the vertical component is going to decrease, so it's going to get smaller in the first half, and it's going to start at the max height. It's going to be 0 vertical velocity, so you're just going to show no upwards arrow, and as it accelerates downwards, it's going to be increasing in the opposite direction. Okay, so for the first half of the flight, we'll say that the vertical velocity is this big, and then it doesn't really matter how big the arrows are, just as long as you're showing that the vertical component is getting smaller for the first half, and then it's getting bigger and bigger for the second half. That's what's important. So it doesn't really matter about your necessity of the length of your arrows, as long as your ideas are correct. So for as it travels, this vertical velocity is going to get smaller. At the max height, there's going to be no vertical velocity, so we're just going to put a dot there to represent that there's no vertical velocity. For the second half of the flight, it's going to have a vertical velocity that's traveling downwards, and so it'll be in the opposite direction. And then at the last stop, it's going to be increasing because gravity and the vertical velocity acting in the same direction, so it's going to increase. Yes, it should look something like this. Should look something like this. So basically, that's your horizontal component stays the same, and this would be your vertical component, which changes throughout the flight. So you can see. In terms of grading for this question, if you have both the explanation and the diagram correct, you should get yourself a merit grade. In terms of an achieved grade, I'm thinking either a correct diagram or a correct explanation. So sufficient explanation or sufficient diagram will get you an achieved, so either or. Josie shoots a ball. The ball hits the back of the net with a horizontal speed of 22 meters per second. The impact makes the net stretch by 15 centimeters. The ball has a mass of 160 grams. By considering the transfer of energy from the ball to the net, calculate the spring constant of the net. Okay, so basically this is a spring constant question. So basically we're given the speed, so velocity so the velocity equals to 22 meters per second. We know that the mass of the ball is 0.16 kilograms. So remember, we always have to convert the unit to kilograms. And the impact makes the net stretch by 15 centimeters. So the distance is 0.15 meters. So remember, we also have to convert every unit of measurement to meters. So this is the three variables we have, and we're trying to find the spring constant of the net. So we're trying to find the K. So in this question, we're going to be considering the conservation of energy. So conservation of energy, that's your EK equals to EP. And right now we have the velocity and the distance. We know that EK equals to half mv squared. So we can work out our kinetic energy of our ball. So kinetic energy equals to half times of 0.16 times of velocity squared, which is 22 squared. If you use your calculator, so 22 squared 0.16. So you should get that your EK should be equal to 38.72 joules. And now we're going to assume the conservation of energy. So we're going to say that EP equals to half kx squared. So therefore 38.72 is going to be equal to half of k, which is, we don't know, multiplied by our extension. Our extension distance is 0.15 meters squared. So basically, if we move the 1/2 to the other side, it becomes 38.72 times 2 divided by 0.15 squared. And that should give us our answer. Our answer should come out to be 3,441.78 newtons per meter. And this question here, that should be another merit level question for this getting the correct answer. In terms of getting an achieved grade, achieved grade could be finding the correct EK, perhaps, or what could an achieved be for this question? So basically, maybe EP equals to EK as well as finding the EK might get you an achieved. Alright, question D. Josie was 44 meters away from Nicole when Nicole passed the ball to Josie in parts A and parts B. Will the ball reach Josie before it bounces? Justify your answer with appropriate calculations. So we want to find out if the range is greater. Basically, we want to find the grade. We want to find the range and we want to compare it to a distance of 44 meters. So we know that our range can be found using the horizontal component multiplied by the total time of the flights. Our VH can be worked out using our SOHCAHTOA rules. Okay, so coming back to our diagram, we can use our SOHCAHTOA. Okay, let's rub this out real quick. So once again, we can use our SOHCAHTOA rules. Okay, so instead of using sine 30 this time, we use cos 30 because the horizontal is adjacent. So we'll say that cos 30 times 22 equals to VH. Cosine 30 times 22. That VH equals to 19.05 meters per second. And we know that our V vertical component is 11 meters per second. Alright, so now we have our VH. We're going to be relying on finding the total time of the flight. So we know that this ball is going to be following the projectile motion, which means that the first half of the flight will be the exact same time as the second half of the flight. So it's a symmetrical parabola. So the equation, we're going to have to use the equation of motion to find out how long it takes for the ball to reach the maximum height. So it starts out with a vertical velocity of 11 meters per second. We're trying to find out how long it takes for this 11 meters per second to reduce to 0 meters per second. This is because at the max height, the vertical velocity is 0 meters per second. So basically, we're trying to find how long it will take for the force of gravity to act to make it 0 meters per second. So we know that our acceleration of gravity is negative 9.8 meters per second. The reason that it is negative is because the vertical velocity is acting in the opposite direction as the acceleration. The vertical velocity is going upwards, however the acceleration is going downwards. So therefore we'll consider the acceleration as a negative interval. And our VI will be considered as the initial vertical velocity, which is 11 meters per second. Alright, and we know that our final velocity will be equal to 0 meters per second. As I was saying, at max height, the vertical velocity is 0. So we can use our relationship between VF equals to VI plus AT. So therefore 0 equals to 11 minus 9.8 T. So therefore we can find out T by doing 11 divided by 9.8. 11 divided by 9.8. That should give us our time to max height equals to 1.122 seconds. However, we know that the total time can be found using the relationship of the symmetrical parabola. So we can say that 2 times of time of max height is equal to the total time. So we can say that if we multiply by 2, so we can say that the total time equals to 2.244 seconds. Now we have our total time and we also have our horizontal component. We can use the relationship of range equals to horizontal component times total time in order to find our total distance traveled. So if we multiply these two together, we will get that our distance is equal to, or our range is equal to 42.76 meters. Alright, and now we need a final justification. So we can say that 42.76 meters is less than 44 meters. Hence, the ball will bounce. So our final justification, we can say 42.76 meters is less than 44 meters. Therefore, the ball will bounce before it reaches Josie. Oh yeah, sorry. And that should be an excellence level question. Okay, excellence level question. To find the range as well as justification. In terms of a merit, if you can find the horizontal component as well as the total time. So finding the total time should be up to a merit grade. And to get an achieved grade, if you be able to find just the horizontal component, that should be enough to get you an achieved grade. Alright, question 2. Halftime at the hockey match. The teams are waiting for the second half of the game. While waiting, the referee swings her whistle in a horizontal circle above her head. Each rotation takes 1.4 seconds, and the metal whistle has a mass of 40 grams and is swung in a circle of radius 0.5 meters at a constant speed. Show that the speed of the whistle is 2.24 meters. So we can use the relationship here between V equals to total distance traveled, D over T. Our total distance traveled in this case will be 1 revolution of the circle, and we know that the circumference of a circle is equal to 2 pi r. So that's also equal to our distance traveled. So we can replace our distance with 2 pi r. So V equals to 2 pi r over T, where this lowercase t can be replaced with the uppercase T, which represents the period. So basically, how long will it take to complete one full revolution of the circle? So V equals to 2 pi r over T. And now we can show that it is 2.24. We can substitute our variables in. We can say that V equals to 2 pi times of 0.5 divided by 1.4. So 2 pi times 0.5. And that indeed gives you a velocity of 2.24 meters per second. And that's rounded to 3SF. And this question should just be another achieved mark here. By determining the horizontal forces on the whistle, explain why it continues to move in a circular motion at constant speed. For this question, we need to be mentioning the centripetal force, so basically the tension force of the string, and what effect that has on the circular motion. So the horizontal the horizontal force, we can say it's a centripetal force. Centripetal force. So this centripetal force is acting towards the center of the circle, and this causes an unbalanced force to be acting on the whistle. This unbalanced force, so according to Newton's first law, if there's an unbalanced force and there's a mass, so the whistle has a particular mass, so therefore there must be an acceleration. And then you can say that the acceleration is basically the rate of change of velocity. So if there is an acceleration, then there must be a velocity. There must be a rate of, that means the velocity must be changing. And then we can link that to velocity being a vector quantity, which means it has both a direction and a magnitude. And we can say that the magnitude is going to remain the same. However, the direction is always changing because the whistle is moving in a circular motion. So in terms of this question, we can say centripetal force acts as an unbalanced. Acts as the unbalanced force on the whistle, and we can link this to Newton's first law. So there is an unbalanced force. So, therefore, there must be an acceleration. There's unbalanced force, therefore, there is an acceleration. You can say that acceleration is rate of change of velocity. Acceleration is rate of change of velocity, hence velocity is changing. And then you can link this one to velocity. Velocity is a vector quantity. It is a vector quantity which has both magnitude and direction. The magnitude, I can't spell, wow. Okay, the magnitude remains the same. So that's your speed. However, direction is always changing. As it is moving in a circle. And that should be your answer for this question, and this should be up to a merit level question. And to get an achieved, if you get an achieved, this is a hard one because I'm not too sure. I mean, if you're able to state that the magnitude remains the same, but the direction is always changing, that could potentially be an achieved, actually. If you link it up to perhaps here, you might get an achieved. So acceleration is rate of change of velocity. That could be an achieved. However, I'm not too sure on that one. Okay, the speed of the whistle is reduced to 1 meters per second. Determine the new size of the new horizontal force on the whistle and explain the likely results of the reducing the speed on the motion of the whistle. So we know that the Fc is equal to mv squared over r. So therefore, our centripetal force is equal to our mass, which is 0.16, times of our velocity, which was reduced to 1, so 1 squared, over r, which remains at 0.5. So we get that our new Fc is equal to 0.032 newtons. So we've determined the new size of the new horizontal force and explained the likely result of reducing the speed of the motion of the whistle. So there is a bit of confusion with this question. However, if we note down the force of gravity acting on the whistle, so force of gravity equals to mg. So force of gravity of the whistle equals to 0.16 times 9.8. And that actually equals to 1.568 newtons. So note that this 1.568 newtons is basically like almost five times bigger than our F of C. So if we go back to our diagram, our F of C is actually our tension force on the string. So that's this tension force here. If this tension force becomes extremely weak, then actually the whistle will actually collapse downwards because the force of gravity becomes too strong and the centripetal force is too weak to keep the circle moving in a circle. So basically the force is not sufficient to keep the whistle changing direction. So you can imagine this in like a practical sense. Like for example, if you're swinging something and then you just slow it down to like a very slow speed, you can just imagine that the ball, the object will no longer keep going in a circle. It will just like collapse down to the ground. So basically, it will just accelerate downwards because your speed has decreased. So that's what we're going to answer for this question. We'll say that we can say by reducing the speed of the whistle, there is no longer enough centripetal force to keep whistle moving in a circular motion. Hence, the f of g will accelerate the ball. It's not a ball, sorry, it's a whistle. Gosh. Hence, will accelerate the whistle downwards. So basically, you can say that it will collapse. And that should be your answer for this question, in fact. So, by reducing the speed of the whistle, there's no longer enough centripetal force to keep the whistle moving in a circular motion. Hence, the FG will accelerate the whistle downwards and it will collapse. And that should get you a merit grade for this question. And to get an achieved, I'm thinking if you can find out the new centripetal force, that should be enough for an achieved grade. Alright, question D. The team is waiting on the sideline. 2 players sit on the bench as shown. The bench is 1.5 meters long and the mass of the bench is 10 kilograms. Each player has a mass of 60 kilograms. Player 1 is 0.25 meters away from the support B, and player 2 is 0.6 meters away from support B. Alright. Draw labeled arrows showing all the forces acting on the bench. Alright, so this involves the 2 support forces and the total FG acting downwards on all the objects. It is important to note down that the size of your arrows or your vectors are very important, because the bench is much far less weight than the masses of the players. So when you're drawing the arrows, your length of your vectors representing the mass of the players should be a lot larger than the mass representing the size of the arrow representing your bench. And that's because they have a larger weight force. So it should be represented something like this. So maybe if you this is just 2 players from the center of mass. These two player 1 and player 2 will have the same size arrow because they're both 60 kilograms, and therefore they will have an equal weight force. So therefore the length of your vector will be the same. So these 2 will be the same. However, for our bench, it's going to be a lot smaller, and that's because it's only 10 kilograms compared to the 60 kilograms. So oh no. So apologies. Let me try this again. Alright, so once again from the center of the bench, and it's going to be a lot smaller. So it's probably somewhere there. And remember, your lines need to be straight. Okay. In terms of your support forces, support A is a lot further away from the players and support B is close to the players. So if you're thinking in a practical sense that if you're carrying something, for example, you're carrying a board, you're on one side and then someone else on the other side. For example, there's a bunch of objects on this board you're carrying. If your side has more objects and if your side is more heavier, then you're going to have to exert more force in order to keep it in an equilibrium. So that's just the exact same case for here. So player 1 and player 2 are much closer to support B than support A. So therefore, support B will be using an increased amount of force in order to support the bench. So hence, the support force provided by B will be surpassing the support force of A. Hence, once again, when you're drawing the vectors, the vector from the support B will be a lot longer than the vector of support A. And once again, that's very important to note down. So it should look something like this. Alright, that's for drawing. And now we have to determine the torques about the point B and then calculate the support forces at each end of the bench. So torque at support B, so we know that torque equals to force times distance. So therefore we have to find the total torque about B. So we know that the weight force is equal to mg. So therefore the F of player equals to 60 times 9.8, which equals to 588 newtons. And the F of the bench, so F of bench is equal to 10 times of 9.8. And this is 98 newtons. Alright, so now for the distances. So player 1 is 0.25 meters away from B. So we'll say that torque at B is equal to 588 times of 0.25 plus 588 times of the 0.6 plus of the weight force of the bench and the distance. So remember the center of mass. So this whole bench is 1.5 meters long, which means that because the vector is at the center of mass, it will be 0.75 meters on both sides. So we'll add 98 times of 0.75. If we add these up, so 588 times 0.25 plus 588 times 0.6 plus of 98 times 0.75. Should get your final answer should be 573.3 newton meters, and that's your torque about B. So now we want to calculate the support forces at each end of the bench. So we know that the torque about B is 573.3 newton meters. Trying to find, and we can use this torque about B to find the total support force at A. So we know the distance between the two supports is 1.5 meters, and we know the torque about B. So once again, we can use torque equals to force times distance. So we can say, this time we can say 573.3 is equal to 1.5, which is our distance, times of the support force at A. So therefore, our support force at A will be equated to 382.2 newtons. Right, so we want to calculate the support forces at both ends. We can use the relationship of the forces up is equal to the forces down because the bench is in equilibrium, okay? So forces up equals to forces down. We can say F up equals to F down. So F up will be equal to your, of course, will be equal to your two support forces. In terms of your F downwards, that equals to your total forces acting downwards. So that's your 588 times 2 plus your 98. So that equals to 588 times 2 plus 98. Not 9.8, plus 98. Alright, so now we can set up the equation. We can say that 1274 is equal to 382.2 plus of f of b. And therefore your f of b will be equal to 891.8 newtons. And that will be your final answer. So you have your f of b, you have your f of a, and you also have your torque at b, which is all the requirements of the question. So now we have to go for the assumptions made. We can say that we assumed that the bench is in equilibrium, and F net and torque net is equal to 0 newtons and 0 newton meters. Okay, so that would be your assumption. Okay, and getting everything correct, so that's vectors, calculations, and assumptions, that should get you an excellent grade overall for this question. To get a merit grade, I think you're looking at calculating one of the support forces as well as drawing the correct arrows. That should get you a merit. For an achieved, I'm thinking that if you can draw the arrows correctly, or you can find the support force of one support force, should be achieved. Alright, question 3, the second half. Later in a hockey match, Nicole takes a penalty corner. She hits a stationary ball towards her teammates. State Newton's third law, which refers to the forces during the collision between the ball and Nicole's stick. So Newton's third law, that's the when two colliding objects meet, they will experience opposite reaction forces. So for example, if you punch someone, you're going to exert a force onto their arm. However, their arm is going to exert an opposite force, which is equal to your punch force back onto your fist. Okay, so that's your opposite forces. So basically, the way to understand this is that if you punch something, for example, if you punch a wall, it's going to hurt your knuckles as well. If there was no force provided by the wall, there will be no pain in your knuckles. So that's the reason if you punch something, if you punch the wall's going to result in the opposite reaction force, which is the exact same as your initial punch. So that's why you would feel the pain in your knuckles. So stating Newton's third law, we can say that Newton's third law is that two colliding objects will experience the same magnitude. Oh, that's really messy. Wow. This will experience same magnitude force in opposite directions. And this here will get you an achieve mark. Alright, so when hitting the stationary ball for the penalty corner, Nicole hits a stick velocity of 18 meters per second. After hitting the ball, the stick continues forward at 12 meters per second. The mass of the stick is 600 grams and the mass of the ball is 160 grams. Calculate the velocity of the ball. What assumptions are made in your calculation? Okay, so obviously this question is going to be a conservation of momentum question. So this will be involving the assume conservation of momentum. Assume conservation of momentum, so that's Pf equals to Pi. So final momentum equal to initial momentum. So we know that P equals to mv. Our initial momentum involves the stick at 18 meters per second equals to 18 times of the stick, which is 0.6 kilograms. Remember, 600 grams is equal to 0.6 kilograms. 160 grams is 0.16 kilograms. So your initial momentum is 18 times 0.6 plus of 0 times of 0.16 because the ball is not moving. So therefore, your initial momentum is just 18 times 0.6, which is equal to 10.8 kilograms meters per second. Okay, so we know that we're trying to assume that our final momentum is equal to initial momentum. So we can write our 10.8 is equal to so after hitting the ball, the stick continues forward at 12 meters per second. So it continues in the same direction. So we have 12 times 0.6 plus of an unknown velocity times of 0.16, which is the mass. So 10.8 minus 12 times of 0.6. This equals to 3.6 equals to 0.16 v. So therefore, our v value should come out to be 22.5 meters per second. And that should be your final answer for this question, which should get you a merit grade. In terms of an achieved grade, if you find the initial momentum, that should be enough for an achieved. Goalkeepers are heavily protected, including the use of leg guards as shown. I can't talk anymore. The ball of mass 160 grams is shot towards the goal, but hits the goalkeeper's leg guards instead. The ball has an initial velocity of 30 meters per second, and at the time of the impact is 0.02 seconds. It rebounds with a velocity of 10 meters per second. Calculate the average force of the impact, okay? So we want to find the force. We have our mass equals 0.16 kg. We have our initial velocity equals to 30 meters per second. And we have our we rebounds with a velocity of 10 meters per second. So our VF is actually negative 10 meters per second. The reason it's negative 10 meters per second is because it's in the opposite direction that it was initially moving at. Alright, so first step, we also have our time. So time of impact is 0.02 seconds. The first step for this question is to find out the change in momentum of the ball. And using the relationship with the contact time and change in momentum, you can work out the total average force of this impact. So we know that our change of our P is equal to mass times of change of velocity. Our change of velocity is equal to final velocity minus initial velocity. So our change of P can be rewritten as mass times of final velocity minus initial velocity. Our final velocity is actually -10. So our change in P is equal to m -10 minus 30, which is our change in P is equal to -40m. However, in this case, we're going to consider the change in velocity as positive, because the negative only represents a change in direction, not the magnitude. So our change in P is actually 40 times of our mass, which is 0.16. So 40 times 0.16, that gives us a change of P, change of momentum is 6.4 kilograms meters per second. Now we can use the change in momentum, and we can use it in the change in momentum equals to F times change in time. So now we can substitute our numbers in. So 6.4 equals to the force we're trying to find times of our 0.02's contact time. So therefore 6.4 divided by 0.02 is giving us our force, which is equal to 320 newtons. And that would be your final answer for this question, and that should net you a merit grade. And for an achieved grade, if you can find this change in P here, I'm thinking this should get you an achieved. Alright, final question coming up. So D. The graph below shows the force of impact over time when no leg guards are worn. Add a second graph to the diagram to show the effect of leg guards would have on the graph shape. Alright, so a pretty tough question, actually, I'm not gonna lie, but if you can interpret this as you have to interpret this in terms of physics, okay? So when there are no leg guards worn, there is a lower contact time and there's more force experienced per second. So assuming that the mass of the ball is the same, so basically with or without the leg guards, it's going to have the same momentum because P equals to mv, the velocity and the mass is the same. So therefore our change in P will be the exact same. So therefore our total force required is actually the exact same. However, the same amount of total force, so the force is basically, you can say it's this area. So this total force is going to be the same, but it's going to be spread over a larger area. It's going to be spread over a larger time because our contact time increases with leg guards. So basically our graph should look something, it's going to have a really wider parabola, and it's going to be the same total force but less average force per second. So it should look something like this. So this peak here will be less than this peak here, and that would be your graph. Okay, so this will be the total force experienced, and this area that we have here is equal to this area here. Alright, so justify your answer using physics principles to explain leg guards benefit the goalkeeper. So once again, this part 2 is pretty standard question, so we have to relate it to P equals to F times change in time. Our change in time increases, and how that would affect force. Alright, so for this question, we can say that we can start this off by saying so leg guards will decrease the average force experienced by the player. This is because with or without leg guards, the change in P will be the same. So that's assuming that the additional weight So additional weight of the leg guards are negligible. So assuming leg guard weight is negligible. Now we can use our so basically our what am I doing? So basically our change in P equals to F times change in time. Our P stays the same, so therefore F is inversely proportional to T. So hence what am I doing? So hence with leg guards, the contact time increases. The contact time increases, meaning that the average force must decrease. However, okay, we're not quite done with the question because the question asks you to explain how it benefits the goalkeeper. So you can say by decreasing the average force, it's going to reduce the chance of injury. By decreasing the average force, the chance of injury will decrease. And you can say hence beneficial. So that would be your answer for this question, and getting up to here is an excellence grade, assuming that your graph is correct. So graph is correct, good explanation, that's an excellence. To get an achieved, I'm thinking an achieved is just drawing the graph correctly, or an achieved could be explaining that the leg guards will decrease the average force experience. So maybe just this one sentence could get you an achieved. For a merit, I'm thinking you have to draw the graph correctly, as well as mentioning that up to the F is changing time, so increasing the contact time, but without the injuries part. So basically, if you stop here, then you probably just get a merit. And another way to get a merit is potentially just writing the full explanation. So full explanation. However, you missed out on drawing the diagram correctly. Could be another way to get a merit. Alright, so thank you for watching this video on the Level 2 2019 Mechanics paper. I hope you all enjoyed, and I hope to see you all in the next one. Thank you.